Welcome to our video tutorial today. We are still handling forces and we have a question to do. The figure below shows a system of coplanar forces. Determine graphically the magnitude and direction of the resultant force. So let us examine the forces. We have the 200 Newton force, 100 Newton force like it has been shown in our diagram. Now, we are going to copy this diagram like it is by drawing a space diagram. So we can examine the forces, consider the angles. This is 50 degrees between 200 and 100. Between 100 and 70, we have 90 degrees, and then 40 degrees between 120 and 70. And the other one is 50 degrees, that is between 40 newtons and 120 degrees. So maybe you can pause that video and go ahead and draw the forces like they are, indicating the angles just as they appear. So you're going to draw a space diagram. So let's indicate the 200 Newton force. So you can place your protractor as that. So we have 30 degrees between the horizontal line here. So 30 degrees and we'll have 100 Newton force. So we count to 30 degrees, it's somewhere here. And then we will have 200, that is in the next 50. So 1, 2, 3, 4, 5, 50 degrees would be here. So maybe you can draw the two forces. Remember, I'm not considering their magnitude. I'm just being careful on the angles. So you can just take your time, draw that. You come to the angles at the bottom. So we indicate the 70 newtons, that is from this line of west. We indicate it's east actually, so 70 after an inclination of 60. So 60 degrees is here. You can place a dot. The next one is after 40 degrees, we have 120, 1, 2, 3, and 4. 120 would be somewhere there. Then 40 in 50 degrees, 1, 2, 3, 4, and 5. Somewhere there. So we can draw the forces. So let's draw the forces like they are in our diagram. That is the 70. So that's the center. Remember, they are coplanar forces, so they all in this direction. Now, begin to indicate the 70 Newton force, the 120, so this is our space diagram. Now, going to draw the vector diagram. Vector diagram. And on vector diagram, we need to consider the scale. So we choose a suitable scale for our drawing. So we have 200, 170, 120, and 140. So I'll use a scale of 1 centimeter to represent 20 newtons. So that in place of 200, I'll have 10. In place of 100, I'll have 5, 3.5, 6, and 40. So I didn't indicate here as our Newton. Now, You choose a point. Remember, we are going to draw from a point a line parallel to this. So you have the angles like they are. And another alternative, remember the 200 Newton force and 100 Newton force are in line. So they are tensional forces. They tend to stretch. So you could simply maybe subtract 200 from 120 from 200. So you'll have the 200 Newton force inclined at 50 and you omit this force here. For 140, because they are also in line, you can as well choose to subtract 40 from 100 and you have the excess here, that is 60 Newton in place of 100. So if we do that, we'll have to omit the two forces and remain with the 3. But for my case today, I'm going to work on with the forces like they are, and maybe we can have time to look at the other alternative, whether we can arrive at the same answer. So this is our scale. Now from a point, you say that is my point. Now I'm going to indicate this as the first force I'm going to begin with, second, the third, fourth, and the fifth. So I'll begin by transferring this force here from my point. So 200 newtons. So you can have one of your set squares lie here, like that. Be very perfect. Remember, this is a graphical method. So going to have a force parallel to that from our point we chose initially. So that is it. So from here you draw that line. So this is of 10 centimeters because our force was of 200 and we remember the scale that we are using. So this will be our point, or rather the nose of our vector, like that. So that one is our 200 Newton. Now I'm going to have a line parallel to 100 Newton force to this point here. Maybe I can erase this, make it a bit clear. So let's go ahead and transfer this force, 100 Newton force. Draw that force in that direction. So it's 100 newtons. From our scale, we'll now have 5 centimeters. So this would be 1, 2, 3, 4, and 5, 2.17 here. This becomes the nose of my second vector. So we proceed with force number 3 to the nose of this other vector. Like that, to that point, begin to draw it in that direction, then measure it 70 to give us 3.5. We are in our fourth force. So that is it, number 4. Remember, to the nose. So like that, we sweep it. So it's 120 to give us 6. So 6 centimeters. So from 1, we begin from 0 to make it a bit easier. So So that is my 120 point to the north of that vector. So I'm remaining with 40 newtons. We do the same. To this other point. So 40 newtons simply with our scale will have 2 centimeters. So my 2 centimeters would go up to that particular point. So we can erase these other particulars. So we can now draw our resultant. Remember, we are making it a dotted from the head of our last force to the tail of the other one. So this is how we do the resultants. So this is our R. So you can indicate your forces. This was a 200 Newton force. This was 100 newtons. This was 70 newtons. 120 newtons from here to here, and a small portion here for 40 newtons. Now let's measure our R. So our R I'm having it as 55. So 55 centimeters, and our scale, so 55 millimeters, that is 5.5 centimeters, and our scale was 1 centimeter to represent 20 newtons. So how about 5.5? So that translates this to 110 newtons. So this would be the magnitude of the resultant. (110 newtons). Now for direction, we're going to pick our direction from the tail of the first vector. So you can have your protractor. You're going to read this angle to be particular here. This would give us the direction of that resultant. So if you project this, this is 40, 55 degrees. So for direction, having it as 55 degrees. So that is all in construction or determining the magnitude and direction of a resultant force using a graphical method. Thank you so much for watching. Please subscribe for more, and let us have your views on our reply section.